Or the bizarre, the mysterious, and sometimes unsettling. I'm Trenton Hooker, and this is Brian Webb.
And we're with our most frequent and favorite guest, Dr. Avi Loeb of Harvard, talking to us about 3I Atlas. Doctor, been a while. What's new?
Oh, a lot of things. Most recently, there was a report about the data from July and August that indicated that they can detect a jet that is wobbling. This is the jet pointed towards the sun from 3I Atlas, which is surprising because it's in the direction of the sun, whereas usually cometary tails go away from the sun because they are pushed by the solar radiation pressure and the solar wind. And in this case, we see a jet pointed at the sun, but it's wobbling. It originates from a base which is very close to the pole of the rotation axis. So just like the Earth is rotating, imagine this object, 3I Atlas, rotating, and imagine the base of a jet very close to the North Pole, for example. And then as a result of the rotation, the jet would move along a cone and will create, just like the beam of light from a lighthouse would basically wobble in the sky. And we see that, and the wobbling is only at the level of 8 degrees, very small angle, but it can be detected by careful monitoring of the direction of the jet. Now, what this means is the jet is pointed towards the sun, and it must mean that the rotation axis of 3I Atlas is very close, within 8 degrees, from the direction to the sun, when the object was very far from the sun and approaching the sun. And the chance of that happening at random is 0.5%. Now, what's even stranger is that this anti-tail pointed towards the sun is still there now that the object passed close to the sun and now it's heading away from, it's receding from the sun. We still see a clear anti-tail jet pointed towards the sun, and now it's actually in the opposite direction to the direction of motion. Now, if the rotation axis is aligned with the direction of the sun, then it means that the object had a permanent day side and a permanent night side as it was rotating. Just think about the Earth. The Earth is rotating almost perpendicular to the direction to the sun, and that's why a given region has daylight, and then that changes to nighttime and so forth. And so in the case of a rotation direction or axis being aligned with the direction to the sun, that means that the object has a permanent day side on the pole that is facing the sun and a permanent night side on the other side. So there was a jet coming from the permanent day side when the object was approaching the sun. And now, as it's receding from the sun at large distances, suddenly there is an anti-tail jet coming from the opposite pole that was previously in the night side. And so why would there be two bases for the anti-tail that are almost perfectly aligned with the poles? And they would be dormant when they are on the night side. We wouldn't see them, whereas they are active once they are in the day side. That is difficult to explain for a variety of reasons. So I'll explain a few of those reasons. First of all, there is heat conduction within any body, so it's difficult to keep one side of the body completely, at a much lower temperature than the other side. If there is a permanent day side and permanent night side, the night side would also be warmed up. But more interestingly, how do you collimate a jet to within 8 degrees if it's coming from the sublimation of a pocket of ice on the surface of a rock? That pocket of ice, when it's illuminated by sunlight, would basically create a full hemisphere of vapor around it. It wouldn't create a collimated jet. The only way to make a collimated jet is to drill a hole in the ground and sort of like the barrel of a gun, shoot the gas out of this hole. But then the chance of sunlight getting into this deep hole is getting small, and it will just happen for a limited time when the sun is above that hole. So it's difficult to get the collimation in a natural situation where you have a pocket of ice warmed up by sunlight. And that's what we find in most comets. However, in this case, we see a jet. And not only that, pointed towards the sun. Not only that, the rotation axis is aligned with the direction of the sun. So all these geometric considerations, they add up to a probability of 1 in 4 billion, just a very small chance of having these coincidences, line up in a way that will give us the antitail, both as the object approaches the sun and as the object recedes from the sun. And of course, if in case it's technological, you can imagine a reason for having a jet in the direction of the sun. For example, in case you want to protect the device, the spacecraft, from the solar wind, you might have a jet that deflects the solar wind from impacting the object.
The European Space Agency, NASA, and 23 other nations have proposed launching this as a drill for a planetary defense system to use 3I Atlas as if it could be something that could threaten the Earth. Now, I wanted to get your take on that, with especially these developments. Are we in a posture where they are in a heightened state of alert?
No, I don't think they're really in a heightened state of alert. I think it may have been influenced by my white paper to the United Nations, arguing that we should monitor with all the assets that we have any interstellar object that has anomalies. That was my recommendation. They didn't embrace it publicly, but ended up with the International Asteroid Warning Network deciding to coordinate observations from hundreds of telescopes around the globe between the 27th of November and the 27th of January. And I'm very happy they did that. But I don't think that they are at the moment worried about any implications for Earth. It's just a drill, a practice. However, I'm very happy they collect as much data as possible, because once there will be some anomaly, it would be impossible to shove it under the carpet of traditional thinking. And so getting as much data as possible is to the benefit of everyone. Even if it's a rock, we will learn much more about this rock, which happens to be quite rare and unusual. And as I mentioned before, the geometric coincidences of this object already raise a suspicion that it might not be a rock.
And Doctor, if it isn't a rock, if it is a spacecraft, if it turns at us and comes our way, what can we do? What should we do?
I don't think we can do much. No rocket on Earth can move fast enough to intercept the object unless it comes extremely close to Earth. But I don't think there is a risk of it changing direction, because it didn't show any indication of that. The non-gravitational acceleration that was measured is really small. It's 1 part in 10,000 or less than the acceleration provided by the sun. So we shouldn't worry necessarily about this object approaching Earth. In fact, I don't even think that if it's technological, the purpose of the visit was Earth. It may have been Jupiter, because it comes to Jupiter exactly at the distance where Jupiter's gravity dominates over the sun's gravity. So perhaps it would like to deposit some technological device at the Lagrange point. We placed spacecraft, including the Webb telescope, at the second Lagrange point, because you don't need much fuel to maintain that position. And so perhaps they would do something like that, in which case we can monitor any new object in orbit around Jupiter. Jupiter would be a likely target because it's the most massive planet in the solar system and was visible to anyone far away from the solar system for billions of years. I mean, the Earth became interesting, as far as we are concerned, only over the past century. Prior to that, we were sort of indistinguishable from nature.
NASA also has the MAVEN mission with that spacecraft, the Mars Atmosphere and Volatile Evolution mission. Can you talk about where that mission had attempted to take some photos of 3I Atlas and did so, but then NASA has lost contact with it? Where are we at with the latest of observing 3I Atlas?
Right. Well, the latest space observatory that gave very useful data is the Hubble Space Telescope, and that was obtained on the 30th of November. I expect the Webb telescope to observe 3I Atlas this week. We will see what data it provides. The Webb telescope is a much bigger telescope, can do spectroscopy, and can tell us the speed of the gas in the anti-tail, the jet that we see. So that will be really interesting. I would like to see if the speed is bigger than expected for the sublimation of a pocket of ice on the surface of a rock, for example. I would also like to know the composition of the jet so we can figure out all of these things with the Webb telescope data. The MAVEN data was shown at the press conference of NASA. It involved a fuzzy image of a glow of hydrogen around 3I Atlas, the first time hydrogen was discovered. Not surprising, because we know there was water, for example, detected by the Webb telescope back on August 6th. So the existence of hydrogen is not surprising. But what's really strange about MAVEN is that a couple of months later, it disappeared. It went behind Mars, at which point we can't communicate with it. But as it came back, there was no signal from it. So NASA is trying to figure out what happened to it. And before it went behind Mars for the last time, we just had all major instruments on it operating. So it's very bizarre that it, more than a decade, 11 years after it was launched, we lost it. The question is whether that occurrence was just a random fluke or somehow related to 3I Atlas.
Doctor, and if I remember right, we're almost out of time, but this comes closest to us on December 19th. Is that right? And what do we hope to glean from that? Yeah,
so it's closest to Earth, but it's within a distance of 269 million kilometers. What I hope to learn is more about the speed of the anti-tail jet and the composition of it, so that we can figure out how much mass it carries and whether it's produced naturally. And I guess these would be the most important clues about the mechanism that makes those jets, and also the interior of 3I Atlas, if the jet carry a substantial fraction of the mass of 3I Atlas. So I'm very much looking forward in the coming weeks to learning more about it, and I'll be glad to give you my verdict on the Loeb scale of whether the object is close to 0, meaning a natural object, or close to 10, meaning a technological object, in which case we will have a very interesting spring in 2026.
That's for sure. Yes. Dr. Avi Loeb, always a pleasure to have you, sir. Thank you.
Thank you, Doctor.
Thanks for having me.
Wow, quite the episode already. I don't know about you, but my vacation plans, I think...
are ruined, or you better get it in first?
I think I better get it in first, right? There could be that chance.
You never know what's going to happen on Unknown. That's why we call it Unknown.
Exactly.
Right. All right, we'll be right back. Welcome back to Unknown, everyone. I'm Brian Webb alongside Trenton Hooker here, and we're joined by a special guest today, all the way from the University of Hawaii, Dr. John Tonry, also an expert on 3I Atlas.
Well, and Dr. Tonry, just to clarify, you and your team discovered 3I Atlas, correct?
That's right.
Wow. So please tell us about the moment where that happened.
Well, it's pretty fun, actually, because we weren't there. We run these telescopes all around the planet. They run robotically, collect data, reduce it, do it all robotically. And this one got detected by our telescope in Chile. And Larry, my colleague, basically looked at the detection on Sunday night, said, oh, that looks good, but sent it in, but didn't do anything more, because he and I had to get up bog early, like 3 a.m. on Monday morning, to hop on a helicopter to fly up to Mauna Loa to our other observatory that's been cut off by a lava flow. And so we didn't know anything about this until we got back on Monday afternoon.
Yeah, I can only imagine the job description, too, for this University of Hawaii post may involve lava.
Yeah. Not always paradise. Right, mostly, right. But not always. Talk to us, Doctor, excuse me, about, we've been hearing about anomalies with this comet. Do you see any of that going on through your eyes?
Well, yes and no. One thing that's really fun about this one is we found it very early when it was still coming in. And so that means we've watched it warm up and do all sorts of stuff, that we haven't been able to see in the two previous interstellar comets. And so for the most part, it looks exactly like the standard comet from the outer solar system that's never been seen before, except it's coming so fast. It definitely came from some other star system somewhere else. And so there's some things that are really familiar. There's some things that are a little bit different. But it's really fun to look at because A, it came from someplace else, and B, it's been traveling for a long, long time through interstellar space. And it's interesting to see what that's done to the poor little thing.
Well, and Doctor, I can't resist, but we just spoke with Dr. Avi Loeb at Harvard. And of course, he had proposed that there is a possibility based on these anomalies and also where this came from, that it might have an extraterrestrial origin of intelligent life. What do you think about that theory?
Well, if somebody wants to make a bet with me, I know which side I'm going to bet on, and I'll give you really, really long odds.
No pun intended.
Yeah. So when the first one came through, it was called Oumuamua, and I was teaching a class with some grad students. And so one of the things we considered is, what's the possibility that this actually might be an interstellar spaceship? And we went through all sorts of stuff. It's fun because it was an order of magnitude thing. And we considered all sorts of things. No. The answer is no. There's just no evidence whatsoever. You need it. It would be very surprising for this to be the first evidence of an interstellar trajectory from some alien civilization. So you'd need really strong evidence to believe it. And there just isn't.
Dr. Loeb was talking to us, sir, about the anti-tail. Have you seen that yourself, and what could that mean?
Yeah, so we saw that. That was one of the first things that we saw when we discovered it. And, basically there's kind of two things that happen. One is the surface gets warmed up by the sun, and what happens? Well, stuff goes evaporating off. So if you can imagine a firework that you fire off, it's following this trajectory, this parabolic trajectory. But if it's one of these whizzy-gig ones, it goes batting every which way. And it goes batting because it's sending off little jets of stuff. So early on, the jet of stuff is pointing towards the sun because that's the side that's getting heated. But then the stuff that starts piling up in a big coma around it eventually gets blown backwards by the radiation pressure of the sun, and it develops this big anti-tail, or opposite the direction of motion. So it's what's expected. There was a spacecraft that went to an asteroid called Bennu, and one of the really cool things as this thing was orbiting around Bennu was it saw spontaneously these little rocks just kicking up in the air, as it were, out of space. And it was just basically the same thing. Little bits of volatiles getting heated up and all of a sudden releasing and kicking things outwards.
Well, that's what I wanted to ask you, too, because Dr. Loeb was talking about on one of the sides that wasn't facing the sun, that there are these jets that were popping up. And I was just curious, is this a latent heat issue where the side that, was facing the sun, obviously with that rotation where there was a little bit of a delay, but is this a natural occurrence, you would say, where those would pop up?
You got it. Exactly right. So one thing to think about is this poor little thing has been traveling through interstellar space for billions of years. And so it probably started out as a really nice snowball, but in the meantime, it's turned into baked Alaska from all the cosmic rays and all the things that have hit it. And so it's developed this surface that's like tar. It's dark, it's red, it's crusty, it's just nasty because of all this evaporation that's happened over the billions of years. When that starts warming up, it's exactly what you're saying. There's heat that goes in, it kind of it doesn't melt the tar, but it starts diffusing in, and then all of a sudden it finds a little pocket of frozen CO2 underneath, for example. And that starts generating some pressure, and then all of a sudden the tar cracks, boop, and out flies some stuff. So there's lots of things that happen on comets that are warming up as they get closer to the sun, and it isn't all just sort of synchronous.
Dr. Tonry, I wanted to ask you too. You were part of the team that NASA funded to create an asteroid alert system. Can you talk about that? And I know the interest too with the international alert system, where they're using 3I Atlas as a drill for future events that might happen.
Yeah. Yeah. So there was actually a George Brown Act that told NASA that they were supposed to find dangerous asteroids that might hit us and cause big problems. And so NASA stood up this Planetary Defense Coordination Office that supports these searches, these activities. And so we got into the game basically trying to find a particular niche where, rather than finding something, 10 years, 100 years before it hits us and trying to mount a mission to go divert it, what we try to do is be alert everywhere all the time. And so if something is going to hit us within a week or a month or something like that, our job is to find it in time that we can move people out of the way. And so it's our particular niche, and I think we do it well. And we tend to find stuff, which is really fun.
I was just about to ask that. I mean, where are we feeling safe that we can catch these things in time and maybe do something about it?
I think it's pretty good. So originally, we didn't know anything about anything. Like, there could be really big asteroids that were going to come in and cloud us that similar to the ones that killed the dinosaurs. And at this point, we know there really aren't any. So the chances of a planet-destroying impact in the near future are essentially nil, because we've looked everywhere and there aren't any. But as you move down and down and down in sizes, there's more and more asteroids. And although the damage from a given impact becomes less and less because they're smaller, they happen more frequently. And so, I don't know, it's probably the case that the average number of people killed per year by asteroid impact is like 100 people, which sounds terrible, but it doesn't work that way. It's like every 100 million years, a billion people get killed, and every million years, let's say 100 million people get killed, or something like that. It's a very, very infrequent thing that is very, very catastrophic. And so if we can get in there and discover something that's about to hit Peoria a month ahead of time, we can predict exactly where and when it's going to hit with very high accuracy. And we can just say, hey, evacuate. There's going to be a big explosion there. It's not radioactive. It's just going to be a huge explosion. Don't be there on this day.
I'm happy to hear it. I don't know about Hollywood. I mean, what are they going to do with all the movie scripts they have written out for our demise? But doctor, tell me, where did something like this come from? Why did it visit our neighborhood, and where's it going?
Well, this particular one, 3I Atlas, it's hard to say. It's not like it came like a rifle bullet from the nearest star. It's been traveling for billions of years, which means we've been going around and around and around the galaxy, and it's been going around and around and around the galaxy, and it just happened that our two little trajectories converged. And what we've learned in the past several years is that actually these are quite common, these interstellar comets. And so at any given time, the odds of one coming through are reasonably small, but every 5 years, there's probably one of this size that comes through. And the reason that we're all of a sudden aware of it now is because it's essentially Moore's law in the Silicon Revolution. We've gotten better and better and better at surveying the sky and processing the data and finding these things.
Oh, that makes sense. And Dr. Tonry, too, with the ability for us to do something, just continuing that conversation for a bit. Now, NASA did, of course, launch its DART mission back in 2022, and did have a measurable effect with doing that. What's your take with the future of our ability to deflect these objects if one did come on the path where we feel like it may cause a problem?
It's really not too bad. We could do stuff. It really depends on how much warning time you have. So there are these meetings every 2 years called Planetary Defense Conference. And it's a very interesting meeting because it brings together the people like me who are doing the surveys, but also people who do civil defense, people who study effects of asteroid impact, and people who do methods for diversion. And so DART was just a kinetic impactor. It came in and hit the little moon, and it was a very small impactor, so it didn't do very much. But if you'd known long time ahead of time that this thing was going to hit us, even a tiny impact early on can lead to the thing missing us. And then, of course, the other mitigation strategies just span the gamut right up to nuclear explosions that cause a much bigger push on it. But the trick is to find it early so that you've got a little push causes a big deviation many years in the future.
Early detection saves lives. That's what they say.
Yeah, for sure.
Doctor, appreciate your time today. Great stuff.
You're very welcome. Anytime.
Pleasure. Thank you, sir.
Well, I was a little comforted by
I
some
think
of that.
so. Yeah. I mean, I think Hawaii sounds great this time of year. I don't know about yourself, but
We should do an in-person interview with him next time.
we should. It has been interesting, though, seeing the trajectory of where all this is going with the first observations to now.
Dr. Tonry, no way. This is definitely a comet. Dr. Loeb, not quite ready to go there.
Right. And there's still so much we can learn from 3i Atlas.
All right. Good stuff. All right.
journey.
Thanks for watching Unknown. See you next time.